Hi and welcome everyone. Thank you for joining our webinar, Leak Frequency Modeling using DNV's leak software. In this webinar, we will discuss leak frequency modeling and give a demonstration of leak software so that you could see how it could benefit your organization. My name is Jessica Pertela. I'm Marketing Manager for DNV's Process Safety, Risk and Reliability Solutions, and I am your host for this session. Our presenter today is James Pickles. James has 16 years of technical safety risk experience and is currently the product owner for the Fast and Safety software products.
Thank you, Jessica, and welcome to all of our attendees to this webinar. First up, I'd like to share the agenda for the webinar. So firstly, I'm going to give a background to leak frequency modeling, and I'll show how leak frequency modeling is typically performed, and I'll give an example of a parts count and how to combine that parts count with historical leak frequency data. Then I will talk about the leak software. I'll describe what the leak software is, and I'll show you how it can benefit your organization. Then I'll review some of the data sources that are included in the leak software. And then I'll give a demonstration of the leak software itself. I'll demonstrate importing a parts count or defining a parts count in the software. I'll show some of the leak frequency outputs from the software. And before we go to a poll question and a Q&A session, I'll show you how you can customize the leak software with your own leak frequency data. So first up is the background to leak frequency modeling. Within the context of loss of containment of flammable or toxic substances, if we consider a typical QRA workflow, we can see that leak frequency modeling is one of the steps in that workflow. And we can see that step highlighted in green in the workflow on the right-hand side of your screens. We can see that we combine leak frequency modeling with consequence modeling to give an overall prediction of risk in a quantified risk assessment. And QRA is just one of many inputs for effective safety management. We can also see in this workflow that one of the steps prior to the leak frequency modeling is for the analyst to define the loss of containment failure cases. Some people refer to these as loss of containment scenarios. In this webinar, I'm going to use the terminology failure cases. We can see an example failure case described in this blue box on the left-hand side. And in this example, a failure case is a medium leak in an isolatable section containing 100 meters of pipework between isolation valves and contains a centrifugal pump. So on this particular example facility, there is an isolatable section that contains some equipment, and the analyst wants to model a medium-sized leak from the equipment within that isolatable section. So the medium-sized leak from that equipment would represent one of the failure cases in the QRA. And each failure case that's been identified in the QRA should be represented by a single leak frequency. In reality, on a typical facility, such as a refinery or a gas terminal or any other type of hazardous facility, you could potentially have several hundred failure cases identified. And each of those failure cases should be represented by its own leak frequency. So if we think about the leak frequency modeling step within the QRA process, there's a range of methods for calculating leak frequencies, but the most typical method in a QRA is for the analyst to perform a parts count of equipment associated with each of the failure cases, and then combine that parts count with historical leak frequency data to give a prediction of leak frequencies for each failure case. And a parts count is a process of typically using piping and instrument diagrams Depending on the stage of the project and how advanced the project is, you might use process flow diagrams. But if you do have piping and instrument diagrams available, then this would represent the most accurate method of performing the parts count. And on those piping and instrument diagrams, the analyst would count all of the potential leak sources or equipment associated with each failure case. There's a few methods for performing a parts count. The traditional method is a manual process using pen and paper. Typically here, the analyst would print off the P&IDs and would mark up those P&IDs with some highlighters, the isolatable sections and the failure cases. And then perhaps on a separate sheet of paper, the analyst would perform a tally of the range of equipment within each section and failure case, and would also make a note of the sizes of the equipment as well. That would generally be a very time-consuming process. Again, depending on the size of the facility and the scope of the assessment, this process could take several weeks to complete. A more advanced solution is for the process to be semi-automated, and this could involve automating the actual counting step within the parts count. And here, for example, the user could use a tool such as Excel. They could import some P&ID images, and then on those images within Excel, they could display some shapes to represent the equipment and size, and then they could maybe have some macros built into the Excel tool to automate the counting of those shapes and make a note of the sizes as well. This would still be generally quite time consuming because it would still require the analyst to identify the equipment by placing shapes on the P&ID image, but it would at least automate the counting process, which would bring some efficiency and would remove some of the human error in the parts counting process. A fully automated solution would involve either some image recognition software or some CAD import software, where that fully automated solution could automatically recognize the equipment on the P&ID images and would also automate the counting process. So this fully automated solution would be the most efficient way of going about a parts count. Moving on to an example of how to perform a parts count and how to combine that parts count with historical leak frequency data to give a prediction of leak frequencies. In this example, we have an isolatable section that has 20 meters worth of 6-inch pipe. It has 2 6-inch valves and it has 4 6-inch flanges. So a relatively simple isolatable section. And the analyst in this study wants to model 2 hole size categories. They want to model a small hole size, which represents a 3-inch hole, and a rupture hole size, which represents a full bore rupture of the pipework. In reality, in a QRA, you're likely going to have more hole sizes than this. Typically, you would have at least 3 hole sizes, possibly 4 or maybe even 5 hole size categories. But just for simplicity, for the purposes of this example, we'll stick with these 2 hole size categories. And therefore, within this example, we have 2 failure cases, 1 for each hole size category. And therefore, we need to predict a leak frequency for each of those failure cases. So to do that, the first step is to gather the historical leak frequency data. And we need to gather that data for the range of equipment types and for the range of hole size categories. So within this isolatable section, we have 6-inch pipes, we have 6-inch valves, and we have 6-inch flanges. and we have two hole size categories, small and rupture. And therefore, we need to gather 6 values for leak frequencies, one for each equipment type and one for each set of hole size categories. Once we've gathered that historical leak frequency data, we're then ready to perform the parts count. And the parts count in this example is that we have 20 meters worth of 6-inch pipe. We have two 6-inch valves, and we have 4 6-inch flanges. So to predict the leak frequencies for each failure case, we simply multiply the historical leak frequency data in the first table by the parts count data in the second table. And it's no more complicated than that. And we can see that on this slide here. So in this table, what we have is predicted leak frequencies for each equipment type and also for each hole size category. And then to give us the total leak frequency for each failure case, we simply sum the leak frequencies within a given hole size category across the range of equipment types. And in this example, what we end up with is for the small failure case, we have a leak frequency of 4.2 times 10 to the minus 4. And for the rupture failure case, the leak frequency is 4.2 times 10 to the minus 5. So that's a very simple example of how to combine historical leak frequency data, how to do a parts count, and how to combine the two pieces of information to give us the predicted leak frequencies. Here I just did it for a couple of failure cases. In reality, you could have several hundred failure cases, but the process is very much the same. So moving on to the leak software and what the leak software is and how it can benefit your organization. In short, Leak is a software tool where you can specify a parts count and you can have the leak frequencies for that parts count calculated for a range of failure cases. And we can represent this by this very simple block diagram. In the green box, we can see we have the leak software, and that leak software contains historical leak frequency data. Over on the left-hand side of the block diagram, we have the user's parts count. So the user or the analyst has performed the parts count outside of the leak software, and they would enter that parts count information into the leak software, and then Leak would combine the parts count with the historical leak frequency data to give the predicted leak frequencies for each failure case. And then the analysts could then use those leak frequencies as input into their QRA software, which could be Safety or it could be any other type of QRA software. So looking at the data sources that are included in the Leak software, by default, when you download the Leak software, it's loaded with historical leak frequency data based on DNV's 2013 analysis of the UKHC's hydrocarbon release database, otherwise known as HCRD. So DNV produced this document in 2013, published this document to encourage standardization within the industry across different users, across different companies, and across different assets. More recently, however, the International Association of Oil and Gas Producers, IOGP, has updated their risk assessment data directory. And they've updated 2 documents in particular that are relevant for this webinar. The first is on process release frequencies, and DNV was involved in the preparation of this document. And this document is based on an analysis of an updated analysis of the UKHC's hydrocarbon release database up to December 2015. So this document effectively replaces the previous 2013 document that was published by DNV. And the leak frequencies and leak frequency functions that are contained within this IOGP report are now included with the leak software. Looking in this document in a bit more detail, this document contains leak frequency functions and leak frequency predictions for a range of process equipment typically found on an installation. And you can see a list of the equipment contained in this report on the left of the screen. On the right hand side, we have the format of the tables in the report. This is an example for steel process pipework, but the format is very similar for all of the types of equipment found in this report. And what you have is a leak frequency function, and that function is defined by a set of coefficients or parameters. And then down at the bottom right, we can see a tabulation of leak frequency predictions for a range of process pipe diameters in this example, and for a range of hole size diameters as well. So the functions contained within this report are now included in the leak software. The second report that IOGP recently published is on riser and pipeline release frequencies. Again, DNV was involved in the preparation of this document, and the frequencies in this document are based on an analysis of a few databases that are shown on the screen. The first is the Pipeline and Riser Loss of Containment database, otherwise known as PARLOC. The second is the European Gas Pipeline Incident Data Group report, otherwise known as EGIG. And the third is the Konkawi report, which contains frequencies for European cross-country oil pipelines. And again, the release frequencies from this report are now included with the leak software. Again, looking in this report in more detail, the report provides leak frequencies for a range of offshore riser and pipeline, offshore risers and pipelines, and also onshore pipelines. And for those pipelines, there's frequencies for a range of pipeline diameters. And also within the report is a table that's not shown here, giving the distribution of the leak frequencies into a range of hole sizes. So within the leak software, we now have the leak frequencies in this table combined with the hole size distribution. So now I'd like to give a demonstration of the leak software, but just before I do that, I'd like to talk about this very simple process flow diagram that I'm going to use as a demonstration. What we have here is two isolatable sections. The first is on the left and is bounded by the red isolation valves. We have a pressure vessel at 50 bar with 50% gas by volume. We have a two-phase stream coming into the vessel, which is 90% gas, 10% liquid by volume. And we have 5 meters worth of 100 millimeter pipework. Coming out of the vessel, we have a liquid stream at the bottom, which has 5 meters worth of 100 millimeter pipework. And coming off the top, we have a gas stream that has 5 meters worth of 50 millimeter pipework. Over on the right, we have a second isolatable section bounded by the green valves. And this contains a compressor which increases the pressure from 50 bar to 80 bar. We have a gas stream coming into it, again 5 meters worth of 50 millimeter pipework, and then we have the stream coming out of it at 80 bar, which has 5 meters worth of 50 millimeter pipework. Also on this facility, there are two main process areas, Area 1 and Area 2. Everything to the left of the red dashed line is located in Area 1, and everything to the right is located in Area 2. And within the leak software, we're able to assign the equipment to different areas, and we're able to sum the leak frequencies at the area level. Within this example, we're going to model leak frequencies for small, medium, and large hole sizes and hole size categories, and those categories represent the hole size ranges that you can see at the bottom left of the screen. So now I'll go into the leak software, and I just want to bring the process flow diagram side by side with the software so that we can see the parts count. So within the leak software, on the project tab, you're able to insert installation objects. In this example, I have just one installation, but if you wanted multiple installation, you could do that, and you would be able to see leak frequencies summarized at the installation level. Within the installation objects, you're able to create area objects. Here we have two areas, area 1 and area 2. Again, you can have leak frequencies summarized at this level in the hierarchy. Then within the area objects, we have the isolatable sections. So within this simple process flow, we have two isolatable sections, section 1 and 2. Within the first section, section 1, which is the one bounded by the red valves, all of the equipment there is entirely located in area 1, and we can see that in the leak software. The second isolatable section, which is the one bounded by the green valves, some of the equipment is in area 1 and some of the equipment is within area 2. So you can see within area 1 we have the section 2 isolatable section. Within area 2 we also have an isolatable section called section 2. Within those isolatable sections, we have equipment groups. In this simple example, I have one equipment group per section, but if you wanted to, or I should say per section within each area, but if you wanted to, you could have more equipment groups per section. And you may want to do this, for example, you might want to have one equipment group for each stream. So for example, if we look at the pressure vessel on the left, we have a two-phase stream coming in, and we have a liquid stream going out and a gas stream going out. So if you wanted to, you could have one equipment group for each of those streams, and you'd be able to produce a report that gives leak frequencies for each of those streams. But just for simplicity, in this example, I've got one equipment group per section within each area. And then when you expand the equipment groups, you get to the bottom of the hierarchy, and then you can insert the equipment objects. So by right clicking on the equipment group, you can see a list of equipment that you can insert. So you can see here things like compressors, heat exchangers, small bore fittings, valves, and so on. So that's how you would insert the parts count. And so what we have here in the first isolatable section, we have a valve which is 100 millimeters over on the very left. It's at 50 bar, and at this stage in the process, it's 90% gas by volume. We have another 100 millimeter valve on the liquid stream coming off the vessel. That's at 50 bar, 100% liquid. And then coming off the top of the vessel in the gas stream, we have a 50 millimeter valve at 50 bar, 100% gas by volume. We have the pressure vessel itself. The maximum connection size is 100 millimeters. It's at 50 bar, and this has 50% gas by volume. And then finally, within the first isolatable section, we have the process pipework. Here we have 5 meters worth of 100 millimeter pipework on the stream coming into the vessel, 50 bar, 90% gas. We have another 5 meters worth of 100 millimeter pipework on the liquid side, and then we have 5 meters worth of 50 millimeter pipework on the gas side. So that's the first isolatable section. And then the second isolatable section within area 1, we have a 50mm valve, 50 bar 100% gas. We have 5 meters worth of 50mm pipework, and then we have a compressor. Here I've taken a worst case pressure of 80 bar, but if you wanted to, you could create 2 compressors, one at 50 bar, one at 80 bar, and you could have half a compressor for each of those. That would be entirely up to you how you wanted to go about it. On the within section 2, but within area 2, we have a 50mm valve, this time at 80 bar, 100% gas, and we have 5 meters worth of 50mm pipework at 80 bar. So that's how you define the parts count in the Leak software. Here I've done it for just a couple of isolatable sections and areas. In reality, you're going to have possibly several hundred failure cases, but like I said before, the process is no more complex than what I've just shown here. Once you've defined your parts count, the next step is to define the hole size categories. So here on the output tab, you can see we have small, medium and large hole size categories. You can create as many of these as you like, and you can name them however you like. You can see here the small hole size category is from 0 to 10 millimeters. So once you've done that, you're then ready to produce the leak frequencies. You can produce reports at different levels in the hierarchy, and whichever level you highlight, the leak frequencies will be summarized at that level and also will be shown for the children of the objects that you've highlighted in the tree. But what I'll do here, I'll just highlight the very top level in the tree and then produce the leak frequencies report so that we get everything. And what we can see in this report at the very top level is we have the leak frequencies broken down by gas and by liquid, and also broken down by hole size category. And then further down the report, we see the leak frequencies summarized for the installation level. Here I had just one installation, but if you had multiple installations, you would have one table per installation. Then you have leak frequencies summarized for each area. So here's the data for area 1. Further down in the report is the data for area 2. Then we have the leak frequencies for each isolatable section within each area. So this is the data for section 1 within area 1. Further down you would find section 2. Then we have the leak frequencies for each equipment group. So like I said before, if you did have one equipment group per stream, then you would see leak frequencies predicted for each of those streams. But here I have just one equipment group per stream. And then finally, at the bottom of the hierarchy, we have the leak frequencies summarized for each of the equipment objects that have been defined within the equipment groups. And again, it's broken down by gas and by liquid, and also broken down by hole size category. So that's the report within the software. You can produce an Excel report as well. And there's several tabs on this report. Again, you can produce this report at different levels in the hierarchy. You can summarize the data at whatever level you select in the tree. So within this report, I won't describe all of the worksheets, but I'll talk about some of the main ones. We have an input worksheet, which summarizes the parts count data. So that could be quite useful for copying into a report. You could format that data or table however you wanted, and then copy into a report. We have a summary worksheet, which gives some charts representing the predicted leak frequencies. We can see breakdown by area. breakdown by segment or isolatable section, and then we have some of the data tabulated. On the frequencies worksheet, we have a very similar report to the one that I showed previously in the software. Leak frequencies summarized at different levels in the hierarchy, summarized for the entire file, summarized for the installation, for the area, for each of the isolatable sections, and for each of the equipment groups. I also wanted to talk about these two final worksheets in this report, which provides the underlying leak frequency functions or leak frequency, historical leak frequency data used in your assessment. And then before we go to a poll question, the last thing I wanted to give a demonstration of is how you can use the software to define your own leak frequency data. So suppose in your organization, you've collected leak frequency data, perhaps across a range of facilities or installations in your organization across multiple years, then you could use the leak software as a place to gather the leak frequency data. And then any users of the leak software within your organization would have access to that same data and would be able to use that data in their QRAs or other types of risk assessment. So on this types tab, you can insert on this user-defined types folder, you can insert continuous or discrete leak frequency functions. So within a continuous object, the format of this function is aligned with the format of the functions contained in the IOGP and the previous 2013 DNV analysis. So the functions are described by a set of parameters or coefficients. We also have discrete objects, and here we have exceedance frequency or leak frequency data for a range of hole sizes within this given object. And you can see the discrete leak frequency function in this graph on the right. So in this example, I've created a couple of objects, one for atmospheric storage tanks and one for relief valves. But you can insert as many of these as you want, and you can name them however you want. So you could use these objects to collect your leak frequency data. Here I have just a few other examples. So suppose that you have access to vessel collision leak frequency data or vessel collision frequency data that have caused loss of containment events or maybe helicopter crashes. And you have that data, you could insert user-defined objects to represent that data. Or perhaps also you have some data for very specific components such as LNG components or maybe hydrogen components. So that's the end of the demonstration, and I'd just like to talk about how you can purchase the leak software. You can do so in the normal way by speaking to your local DNV sales manager, and the poll question that's to follow, you can respond to indicate you'd like your sales manager to get in touch, or you can contact us at digital@dnv.com. Alternatively, you can purchase the leak software directly on DNV's marketplace at veracity.com.
Thank you to our audience for joining us today. We hope you found the information useful in your work. See you next time, and goodbye for now.